welcome to the session which we are conducting on deployment. Basically, deployment is a way where we can show what will be the output of our models to the end user. End user, when we say the model which we have built for the customers, right? So there are multiple platforms to deploy the model. So today we will be giving you how Streamlit can be used for the this process. So today with us, Nishit is there. So Nishit, you can start.
Yeah. Hello, everyone. Hope you're having a good morning. Like Shubhangi said, like we all are living in a world where data has taken up like a lot of our daily lives. Every day we're dealing with a lot of data, and every day we are dealing with a lot of algorithms running behind the data to make sense of that data. So machine learning is basically handling data and predicting other data, taking in some certain variables or something like that. So the thing with machine learning is we have a lot of resources to actually build ML models or predict data or classify data. But we don't really have enough resources to present those data credibly to someone. Because let's say you are in a position where you have designed a great machine learning model which does a great prediction, and it is like accurate, and it has pretty good performance metrics. But the thing is, if you can't present it to someone, let's say someone who is in an office remotely located to yours, and he wants to access your model on the go. He can't really switch on his laptop every time, go to Google Colab and then or Jupyter Notebook and then run the algorithm and then take stock of what the algorithm is doing. So this is where web apps come in. So web apps these days take in data like whatever the users provide, and they in the backend they run their ML model, and then they predict whatever is required of the machine learning model to predict. So web apps using machine learning model will really help people to actually present their ML models in a more appealing and more accessible way to other people who are not really well versed with Google Colab or Jupyter Notebook. Because let's say you are presenting your web app to a layman who doesn't know what is Google Colab, who doesn't know what is Jupyter Notebook, but just wants to get the output of whatever input he's providing through the model. So for him, it will be a tedious task to actually go through the entire environment of Google Colab, Jupyter Notebook, installing the libraries and stuff. So this is where ML web apps make it really accessible from remote locations, from your PC, from another PC, and these days from phones as well. So yeah, today we'll be focusing on building a web app out of your machine learning model using frameworks which are inbuilt in Python. It is actually a library which is inbuilt in Python, and it's called Streamlit. So Streamlit has been around for quite some time, but it has recently gained popularity because of how easy and well versed it is to use in building your ML web apps. You need no prior coding knowledge except your basic Python for machine learning and Python for data science, and you can write easily like Streamlit codes and convert it to your web app. So without wasting much time, we'll straight away jump to the situation at hand over here. Let's I'll present my screen and we'll look at what we're going to see right now. So yeah. Okay. I guess my screen is visible. Can someone confirm from the host if it's visible?
Yes, it is visible, Nishit.
Cool. So yeah, here we'll be focusing on okay, this must be this must be looking like a lot of code and not making any sense. So we will go through the code one by one, and I'll show you what the output is and how it's changing with respect to your code. So today we are taking the Boston dataset, the Boston house price prediction dataset. So the Boston price prediction dataset is an inbuilt dataset that you can like import from Python itself. You don't need to download the CSV file. So you can just like you can from sklearn you can import the datasets, and then you can import the Boston dataset from over there. But we will be making a web app out of this. We are not going to just stick to our common ML algorithm of prediction of price. We'll make a web app out of it. So yeah, first we'll import all the libraries. Like I said, Streamlit will be used. So Streamlit as ST. Pandas, obviously we need it for pandas operation throughout all our data frames. I'll come to this SHAP in a while, what this SHAP does. As of now, you can totally forget what SHAP does. Then we'll come to lib.pyplot as PLT. Okay, this will be helpful for plotting your charts and your graphs. And from sklearn import datasets. Datasets will be, this is from where we'll import our Boston dataset. Random forest regressor, obviously we need this. Like the whole point of this is we are actually employing a machine learning algorithm. And then we'll import Plotly Express. Plotly Express is just a library which is like, which just generates beautiful charts, beautiful graphs of your data. So, and it's like interactive version of your matplotlib. So yeah, okay. We will straight away jump to how what all you need to actually make this work, your requirements and all. Okay, so first.
Nishit, sorry to interrupt you, Deepak this side. There are a few questions which are coming on chat and Q&A. Please note that most of these questions will get answered during the presentation itself. If something is there, we will take all the Q&As at the last of the session.
Sure.
So I'm noting down all the questions. We'll revisit that at the end of it, right? So let's go ahead with the presentation right now.
Good.
And also, if you guys have any questions who are listening to this, you can note it down at any point of time and post the question. We will take it up at the end of the presentation. Nishit, please go ahead.
Sure, fine. Okay, like yeah, as Deepak said, we'll take up all the questions at the end of the presentation. I'll explain whatever notes you have. Yeah, so we'll come into the requirements that you actually need to actually build this. So like I said, you need like you can't put this on Google Colab. As of now, let me make that very clear. You can't host it on Google Colab because Google Colab doesn't give up web hosting as of now. You have to install certain other dependencies in Grok and stuff like that for presentation, for your web app presentation. So you can't work with this code on Google Colab. So you have to work on this in your local system. You can install Anaconda. I'll show you where you can install it. So Anaconda is basically, you can go to your Anaconda individual edition, and then you can download this for Windows. I've already downloaded it, so I won't download it. It's a graphical installer. You can download it. All sorts of Python related work you can do in your Anaconda. So after you install Anaconda and the path is added to your system, you can like use you can use it for running Streamlit on the top of it. So I'll open my terminal now, and I'll present the web app so that you can see what all changes are actually happening live, like not just the end product. So I'll just this line of code that I'm typing over my terminal, Conda activate base. This actually Conda is a keyword of Anaconda, and activate base as in base is the environment name. So it's just like I can give it Nishit if it's possible. I don't have an environment name Nishit, so I have an environment name base. So I'm naming it as I'm running Conda activate base, and then I'll run the app on top of this environment. So I'll pass on the code Streamlit run, then the name of my app, that is boston.py, and we'll have the we'll have the web app over here. So this is the web app that we were talking about. I'll put it over here, and this one, good. Okay. Yeah. So this is all the libraries that we imported. This is obviously not visible over here. st.set option, this is used for okay, so this matplotlib.pyplot, it's actually not compatible. Like matplotlib.pyplot hasn't been like regularly updated, so it shows a deprecation warning. You can turn that warning off by setting the option that don't show me the deprecation warning, so you can set it as false. Now this st.write, this is used to basically put up headings in your web app, st.write command, and whatever you need to write in your web app, you can just use the st.write command, and then it'll give you the link. Okay, you want, like, let me show you how it's changing like on live. So this app predicts the Boston house price. Let me just change it something and save it. So it'll like quickly it'll show me that your source file has been changed. Let's rerun it. So we'll rerun it now, and it'll show me, okay, now it's Boston price. So this is just a basic yeah, this is just the basic application, like how you're changing stuff over here and gets changed live over in your web app. Now, okay, we'll jump to the description of the dataset that we are taking. We've already explained st.write functionality. So Boston House dataset has this attribute called CRIM or crime actually. So it's the per capita crime rate by town. And then we have ZN. ZN is the proportion of residential land zone for lots over 25,000 square feet. Lot of jargons. This basically means this is the land that has been allotted per 25,000 square feet for residential purposes. So then we have indus. So industry is like the proportion of industry occupied per acre of the town. So the first one was for residential purposes, and now this is for industrial. This chas is a binary binary attribute. 0 means no river is present nearby the residential plot. 1 means a river is present by the residential plot. NOx or nitrogen oxide concentration, it's just a pollutant. So it's mentioning that this is the ppm, like this is the level of pollutant around that particular place. RM is the average number of rooms per dwelling. So let's say you're like it's a 10 BHK house or something, and there are 2 people, so it's like 5 BHK per person. So it gets averaged out like all the rooms present in the entire city divided by the population of that particular place. So yeah, then we have age. This is the proportion of owner occupied units. This basically means how old is that house. So then we have this is the distance from the nearby offices, the office or the IT complex or something. Then we have radial or rad, it's distance from the highway of that particular property. Then tax is the property tax that is being calculated for that property or that particular house. And then we have PT ratio. This is basically for children, like how many teachers exist per student in that particular area. So then we have B, number of black people living over there. And then we have LSTAT. LSTAT is the per capita crime rate by town. So, okay. Then we'll jump in straight to the dataset. Okay, this is the dataset that we have over here. Okay. Now we've okay. We've already loaded the dataset, the Boston price dataset over here. So from datasets.load Boston. Now we'll classify our input attributes as X, and our target variable, that is the median price of the property, a median value of the property, as our target column, because we are predicting the value of that property. So it will be our Y, because this Y is what we'll be predicting today. Now we'll classify, like we'll assign this to another a data frame. Basically, this is not in a data frame. This is just this we've just loaded the data set. Now we'll load it into a data frame and call it DF Boston. So this will be the referring data frame throughout this entire program, this entire app. Now we have loaded all your X and Y. We have already written our I've created our data frame. Now we need to show this data frame to the user. So we can simply pass on st.write and then the name of the data frame within that particular as constraint, and it will display you the data frame that is over here. So if I just remove this, I'll just remove this and rerun it. Boom, the data frame is gone. So this will be yeah, okay. So we'll keep the data frame for understanding purposes and analyzing what the data set is actually containing. Okay, now we'll come to the visualization part. This is where things will get things get really interesting, and I'll show you a lot of functionalities of actually Streamlit, how we are generating all of this. So in visualization, I've created a variable called chat select. So st.sidebar.select box. Okay, this st.sidebar, this st.sidebar is basically used to push certain sections of your web app into the sidebar, like not clutter the entire mid zone of your like the middle working space of your web app, but like to make it more visually appealing and push it to the sidebar. You can simply, you have the option to remove the sidebar function and just stick with st.select box and rerun it. You will now see it over here, the select the type of chat, you can select it. But for making this middle section like less cluttered, we'll be putting it on our sidebar as of now. I'll show you how the sidebar is what the sidebar is looking like in a while. So yeah, we'll rerun it, and again it's pushed to the sidebar. So this is the sidebar that I'm talking about. There are a lot of details over here in the sidebar. I'll come to it slowly. So here you can select your like chat that you want, box plot, or let's say you want let's say scatter plot or anything. It's running over here, and it'll then show you whatever you want to see. See, considering this is like this is of continuous variable, we'll not be employing line plots and all. We'll be only using scatter plot as of now, because line plots and all will not make much sense for visualization. So we'll stick to scatter plots. Okay, so scatter plots will plot it let's say yeah, okay. So we'll plot, let's say, crime over, let's say, amount or target or something. So yeah, so this is basically a scatter plot. Now we'll come to okay, why this, like how this is working. So I've already shown you that we have declared this variable called chat select. So st.sidebar.select box. Now the sidebar function, as I said, it pushes the like particular element of that web app to the sidebar. Now select box function is where you get to select from the options that are present. So there are two parameters that we can pass in select box. Label, that will basically show whatever like it's written over on the top. Select the type of chat, or you can just like, let's say I'm removing this type of chart. So it's can be changed, yeah, to type of chart. And then we'll have options. So this is where you can choose your options. Options, these are all the options that you can choose, and it'll be passed within the options parameter. Okay, so after we have passed it into options parameter, we have a chart select we have a chart select equal to scatter plots, or we have a chart select equal to line plots after you've chosen it. Now we need to convert all the columns in our data frame which have numerical data, which is basically all the columns, into one list that will contain all the column names. So this numeric column is a list that consists of all the column names that are of the type float and int. So I'll just show what this numeric column is containing. Right of numeric columns. Okay, save it. Okay, so this list is containing basically all the columns that have numerical data. Here you can see that it's like total from crime till target target variable. So this is a numerical like this is basically a list that will contain all your target variables, like all your input variables and target variables. So now that we have gotten like we've got our list of all the parameters. We will now plot it. Okay, so like if we have selected chart select, this is just a basic if else statement. So if we have selected chart select as scatter plots, so we'll get our here we'll get our scatter plot settings. So we'll have, and again, st.sidebar.select box that will show up when we select scatter plots, and show us what do you want to put it on, what do you want to put on your x-axis, and what do you want to put on your y-axis. So yeah, we'll let's say, and here, like we have already seen st.sidebar.select box options, we need to pass an options parameter. So here our options will be the list of all the numerical columns that we generated in the previous section, that is numeric columns. So we have a like liberty of choosing any variable from this list of column, like list of column types, like list of attributes in that particular list, and we can choose it to present it in this options section. So x-axis and y-axis will like decide by that only, by passing in numerical columns as our options. So this basically will give us the liberty of choosing all the columns. Now we'll come to plotly.express. So we have already declared plotly.express as px over here. So we've imported it. So we'll use this plotly express to like generate our scatter plot. So excuse me. So yeah, we have px.scatter. We'll have a data frame is equal to df Boston. Like I said, this is our data frame throughout this entire duration of the code. And we'll have our x as x values and y as y values. So we have already like received our x values, the one that we'll be choosing from this list of columns, list of column names, and then we have our y values, which will be like decided from this only. We'll be choosing another y value from our column names. So in the sidebar, you can see where you're deciding your x-axis and y-axis values. So these are all the column names that you have got from your variable numeric columns. So you can choose anything, and then you can like plot your scatter plots. Similarly, we have for histogram. Basically, if you choose histogram, is basically the same thing. You just change this px.scatter gets changed to px.histogram. And instead of x-axis and y-axis, histogram only needs one axis. So we'll have just one. I'll show you how the histogram is plotting the variables. So yeah, this is the histogram. It will have only one attribute, and it will show us the counts of all the attributes that are occurring. So tax. Okay, so this is just a basic histogram. And if you want to plot a line plot, you can change it to px.line. Again, we have to choose x values and y values. Let's say I'm choosing line plots. So yeah, this is not making a lot of sense because it won't. It's continuous data, and more like it's more suitable for a scatter plot visualization. Then we have box plot. Similarly, you can choose px.box and then plot your variables. So yeah, this is a box plot. You can zoom in and actually look at what the box plot is doing. So yeah, plotly.express gives you the opportunity to zoom into your graphs, zoom out, save those plots for future references. Then you can also like you can hover over your data points and know which part of the data frame are they actually pointing to, what will be the actual tags over there. So yeah, plotly express is good in that because it's basically an interactive form of plotting. So yeah, now we'll come to what I was showing in the first place, this particular thing, specify input parameters in sidebar. Now the thing is, we have already discussed how we are pushing stuff to sidebar, so we don't need to again discuss why we are pushing this into sidebar and how we are doing it. So I'll assume we are having a clear knowledge of how the sidebar is functioning, and I'll show like what we are doing in this particular section. And yeah, mind you, like if you have any doubt, you can put it up at the end of the end of the webinar. We'll obviously address it. So yeah, so we'll now we have declared st.sidebar. We have pushed this element to our sidebar, and when we are discussing like declaring a header, so this is our header, specify input parameters. If I don't put it like header, I just put it st.right, it'll show me like this small teeny tiny text. So I put it as a header so that like it's telling me, okay, this is the section that where you need to specify all your input variables. Now we'll define a function. So user input features. This user input features will basically take in your like values from like it'll take in values from the user for the prediction part. So I'll tell you how it's doing that. So we are declaring a variable CRIM because of our data frame, and then we are taking st.sidebar.slider. Okay, st.sidebar. We discussed this already. Push to the side. We have pushed this element to the side, and we have a slider now, a new thing. Okay, so slider is basically how you declare. Let's say you've declared a like number a equal to 5. Slider is basically an interactive way of declaring a equal to 5. You'll have the option from 1 to 10. You can slide your bar and then choose, okay, I need to put it as 5. I'll put it as 5. So here what we are taking is, this is float, okay, float x dot crim dot min. So this is our lower end of the slider. So, and this float x dot float x dot crim dot max is the higher end of our slider, and this float x dot crim mean is basically the default value that will be set in this particular section. So you can change this to see how it's working. I'll just change it over here. Let's say I'll choose 1 to 300 and then specify 20. So 1 will be the starting value, 300 will be basically the end value, and 20 will basically what will be already set in that particular slider. So hold on just a second. Okay, we'll rerun it. Okay, so now you have the liberty of choosing the variable from 1 to 300, and as I said, the default value will be set as 20. So this is how the slider is working. So this is basically like an interactive way of setting your input attributes. Now we'll like change this to its original state. Yeah, so we are basically, this is a float version. So float of like we are basically taking an input for all the variables, like all the like attributes, and then we are declaring sliders for each attribute, and then we are storing the values in these variables called CRIM, ZN, Indus, CHAS, NOx, RM, age, and further so on. So yeah, we have declared all these variables. We have, this is our data. So this is basically like this is what we have stored. So basically the column name lstat is like pertaining to this particular variable that we have declared lstat over here. PT ratio to this PT ratio variable that we have gotten from here from the user, and then tax from what we've gotten over here from the user. So basically that's how the slider is working. Now we have defined, now that we have defined all of it, we will be putting we'll be declaring our functions and all, inputting the model and all to do the prediction. Now, this is the easy part because we have a lot of libraries that can do that in a jiffy. So we have our declared our df. So we have declared all these input variables as one single row data frame. So you can see it over here. I'll just push this sidebar to the left. So this is the specified input parameters. So this is what you have declared in the sidebar. Now this is also dynamically changing. Let's say I'm like changing this to 167 or something. Let me change it. 35.84. You'll see this will get changed to 35.84 in a while. It's running, yeah, 35.84. So it dynamically changes whatever you're declaring in the sidebar, and it'll we'll come to like inputting the model and all. So here we have already included, like we have already inputted the random forest regressor from sklearn. So we're using that model and we're fitting x and y in that. X is basically our input variables and y is our target variable. We've already discussed, like declared it over here. X is equal to our input feature names and y is our like median value or the target column. So we'll fit it in the model dot fit x comma y, and we'll apply the model to make the prediction. So prediction, whatever the predicted price will be, we want to print that prediction. So we'll declare a header again, prediction of median value of house. So this prediction of median value of the house, this will keep on dynamically changing as I change my inputs. Change my input, so it's it's changing. You can see the median value of the house. This is in $1,000, so $20,000 or something will be the median value. So this is how the prediction thing is working for the machine learning model. Random forest regression is the model that we've used over here. Now there's another feature of this. We've improved, you can access this using this link that I have put it in the code, github.com/slundberg/shap. So shap or Shapley values, it's just like you have various techniques to get feature importance. So this is just a technique to get your feature importance. You can just this is used for getting your visualization, which features are being taken by the model. If you discard this entire snippet, your code will just work fine. But I've added this so that you can know which all features are actually contributing towards your prediction. So Shapley, actually Shap is just a shortened version of Shapley. So it's based on permutation feature importance. It will be you can remove this if you want to, but you can let it stay so that it can you can see what all how the model is deciding on the important features. Now we'll come to how we are visualizing it. So now we have an if st.button. So st.button is st.button will show okay, we have this st.button. St.button, if it's clicked, then it triggers this function st.header feature importance. Then it plots this two plots. So this is basically the label that will be visible on that particular button. So I'll just remove that show shap graphs. Save it, rerun it. Yeah, so it'll change. This thing will change to show shap graphs, and then we can. I'll click on it. You'll see the graphs of feature importance, how it's deciding. So these are all the variables that we have, and which all are contributing majorly to the prediction of the target variable. So the red values means high prediction and blue values mean low prediction. So now this is a median line. Okay, so it's saying that if the value is less than 0 of LSTAT, LSTAT value is less than 0, it is it has a high impact on the model output. And if the LSTAT value is greater than 0, it has a relatively low impact on the target value. Now, similarly, if RM it's greater than 0 or whatever this value is, if it's greater than something, then it's highly highly affecting the target variable. And if it's less than this certain value, then it's not that impactful for that model. So this is basically, if you can't make excuse me, if you can't make sense of this, you can basically plot another feature importance graph, which is basically a summary plot. So so you can get LSTAT, RM, dis, crime. So this is verifying this in support of what we have predicted over here. LSTAT is highly impacting, and then we have RM, then we have dis. So yeah, this is how the model is working. Now we'll come to if you have understood how we are depicting presenting the model. So we have already declared conda activate base and stuff like that, and then we have locally hosted this. This is basically a locally hosted version of the web app. Now you must be wondering, okay, I've hosted this locally. How do I actually host it on somewhere where I can present it to someone without having to switch on my laptop? I basically send them a link or something, they open it and they get to know how it's working and all. So there's an easier version, very easy way to do this, and a complex way. Complex way would be to host it on Heroku or something. Then you have to declare your proc file, then you have to declare your web server files, which is basically the same file for every basically every Streamlit app. but we can make it easier if we use the inbuilt inbuilt feature provided by the Streamlit library. So Streamlit, you can host your web apps using Streamlit's inbuilt function. So let's say but for that you have to visit their website and host it. So I'll show you how you can host this web app like this over a particular link, and I'll send the link to you so that you can see how the web app is actually behaving. So for that you need a GitHub a GitHub account. So yeah, we'll move on to our GitHub account. So this is our GitHub account, and this is your Streamlit account. So basically I'll guide you through how you link your Streamlit and GitHub. As of now, I'll sign out. So yeah, you can continue with GitHub or continue with Google. But I'll advise you not. It's the only way. You need to continue with GitHub so that you can host your web apps to Streamlit. So we'll continue with GitHub. Then it will ask me which account that I want to use, or it'll straight away sign me in because okay, just a second. Yeah, okay. I have this account over here. It's logged in. Now we'll first of all, before we host the app, we need to host it on GitHub. So if you're familiar with GitHub, you know that you have to create a GitHub using create repository. So we'll click on create repository and create our repository, and let's name it as Boston Web App. Okay. So this is we'll keep it as a public repository. Mind you, you have to keep it as a public repository so that you can host it on Streamlit. Now we'll create this repository. Okay. So now that you have created it, we need to upload files to our repository. Now for uploading, here comes a key part. We have seen this code. We have written this amazing code. This will basically be our main file. But Streamlit doesn't know what to do of this because it needs certain dependencies to be installed so that it can actually show me the web app, how it's working and all. So we'll come to the extensions. Okay, we'll see how we are declaring it. So there's this requirements.txt. Okay, so now you must be wondering how you can get requirements.txt of this. Basically, you've taken all the libraries that you have used over here: Streamlit, Pandas, SHAP, Matplotlib, sklearn, Plotly, everything, and you declare their version names, the latest version names. You can get it from the website itself, from their particular websites of what version they're actually based upon right now. Or there's an easier thing you can do, you can just run a pip command in your CMD and get it. But after you've after you've generated all these numbers, I'll show you how you can do it using Google. Okay, I'll just let's say we have Plotly Express. So Plotly Express will show you what version it's actually based upon right now, 0.41. But we have using an advanced version. Okay, just a second. So you can get your Plotly Express version. Let's say you've declared 0.40, but it is moved on to 5.4.1 already. So you can use 5.4.1 if you want to. Yeah, so this is basically a requirements.txt. Streamlit is currently based on this latest version, so you need not do that. Basically, you can use the rudimentary ones as well, but Matplotlib may generate problems if you use the rudimentary thing. So you can pass on this. Okay, I need to show you how you can get your pip list. Just a second. Okay, we'll run it over here. Okay, so this is even easier way to get your pip list, but you have to basically search your particular libraries. So I pass this command called python mpip list. So it will give you the list of all your libraries that you have on your system right now installed using pip, and it'll show you their version names. So we've used sklearn, we've used pandas. So we'll come to pandas. Let's see, where is pandas? Yeah, here is pandas. So pandas, we have 1.0.1. So basically we pass it on the requirements.txt file as pandas is equal to 1.0.1. Then we'll come to Streamlit. Okay, Streamlit, we have 0.69.2 installed on our system. So we'll pass it on as equal to 0.69.2. So basically you can declare all your like you can get all your requirements from this particular command. So that's it. That's the legit the last thing you have to do, and then you can basically get on to hosting. So we'll come to our file, repository. Then we'll create a new file. Let's say we're creating a new file. I'll name it as boston.py. Okay, you can straight away import it. Import your file from your PC. I'm just doing it in this way. So I'll save it. I'll commit this new file to my GitHub repository. I have boston.py. You can also import your files directly. You can add your file from select upload files, choose your files, and then go to requirements.txt. Yes. So it'll upload your file. We'll commit our changes. So yeah, we have our boston.py and we have our requirements.txt. You can host it now. I'll take this link of this GitHub app. Now we'll go to new app. Now it'll ask you authorization access. So it'll take full control of repository hooks. This is mind you, it'll take access to both public and private web apps, public and private repositories. Please don't put anything that you don't want to be visible to everyone else. So you can authorize Streamlit. After you authorized, Streamlit will direct you to its website of declaring the link and all. Yeah, okay. So we'll paste our repository name. It's already showing our repository name. We already have it. So this is boston.py. So this is our main branch. This is our repository path that is existing, or you can just paste your GitHub URL and it'll fill it up directly. So now we'll deploy it. So here comes the crucial thing. You have to deploy it. Now let's deploy it and see how it's getting deployed. So here it will run, it will provide you a machine on the cloud. Basically just a copy of your system. It will take in all the requirements.txt and then it will show you how how it's replicating the entire process on a cloud machine. So yeah, it's basically your app is in the oven. So it will generate our web app now. And after that, you can send this link to anyone you want to, and they can visualize it. Yeah, it's a time-taking process, so you have to be a bit patient. Okay, in the meanwhile, I'll read some questions. pip3 freeze requirements.txt. Yeah, you can use that as well. pip3 freeze requirements.txt. Yes. Can you show the XCB regressor model? Yeah, you can basically use any model, Soumya, on this. I've for simpler purposes, I've used this random forest regressor. You can use any model that you want to. How do you install Streamlit? Okay, Streamlit is just a library. You can install it using pip install Streamlit. I'll show you. Install. So it'll show me its requirement already satisfied. So the requirement is already satisfied. So obviously you can type in pip install installed in your particular system. If you don't have pip available, you've installed Anaconda, you can install it using Conda as well. So I'll just show you how to do that. Let me activate Conda. Just a second. Not yet. So you can use conda install Streamlit as well. It will collect your stuff. Requirement already satisfied. It will give you the same it will give you the same thing basically again. Requirement already satisfied. So yeah. We'll look at our web app. Okay, it's still installed. Okay, it's installed. Yes. Yeah. So now you have the web app. I'll paste the link over in the chat and you can like visualize what we have created now. You have everything everything basically. The entire web app is hosted on web now. You can basically send it to anyone, like your colleague or your friend or someone in like a professor who wants to look at it, or some hackathon that you participated where you want to actually show the like outputs not on a collab but actually through a web app. You can send it. I'll paste it on the chat box. From where can I get detail in the code? I want to practice these kind of framework. We'll provide this code at the end of the webinar. I'll provide the GitHub link as well. You can see like how we are doing it and how the code is working. So yeah, this is the link. Please you can access it and see how the web app is working. So we have successfully hosted our web app, and so basically right now, if you want to share it with anyone else over your let's say colleagues and all, you can share it and they can access it. Loading external data sets. Yeah, you can do that. I'll tell you how. Just like you did this boston.py requirements.txt, you have to put in your CSV file over here. And in the code where we have declared our data set as boston.data, boston.target, and we have basically generated a data frame, you can do this df is equal to pd.read CSV and then pass on your path. This is basically whatever working directory that you have over in that particular project. So this is what it will look like. You can pass it over there like this and put your CSV file in that GitHub, and you can access it. So yeah, I have tried pip install Streamlit, this on Python notebook. But do we connect Python notebook to Streamlit like PKL filers? Do we connect Python? Okay, no. Listen, pip install Streamlit. You have used this on Python notebook. Sadly, you can't do this on Python notebook. ! Pip install. I mentioned it in the start that Python notebooks you can't really host it because you have to install other dependencies as well. This basically is for a security reason why Google and other Python notebook providers don't allow you hosting web apps using their inbuilt native IPyNB interactive IDE. So you can't do that in Google Colab. You have to install one thing called ngrok. So ngrok, you have to go into there. It's just a localhost provider system, like service. So whatever you're doing it over here, you're hosting it on localhost, it will basically provide another localhost in another system, and you can host it. So for that, you have to install ngrok. You've already saved module. Okay, I couldn't read the question. Okay. So yeah, this is how you can host your web app. You can ask me questions and doubts, whatever you have. I'll take in all the questions. Yeah, let's go.
Yeah, Nishit, I'll moderate this now. I think okay. Jitin, I think you want to ask questions. Raise his hands. I'm going to unmute him so we can discuss. Good. Yeah. Okay, I'm not able to. Shubhangi, can you unmute?
Yes, please. I'll do that.
Sure.
Yes, Jatin, you can.
Yeah. Hi everyone.
Hi, Jatin.
Yeah, we were this was the correct timing for us. We were working on our last client projects and we were trying to implement or deploy this using Streamlit. So for the past 1 week, we were researching, reading, doing things using Streamlit. Then this class came up. like what happened is like we have already done the whole regression model and took the best, regression classifier model and saved a model for this. Then what we have to do, we wanted to do is like we have to create this, save this model into the visual code or the spider or anything, any IDE.
Okay.
And loading that model into this IDE and taking the input from the user to create the prediction.
Okay. Okay. So basically, you want to like have a model and then like use that model in that web app for prediction, right?
Yes.
So yeah, you can do that. You can create your PKL file and then you can use that model similarly, like how you would use in normal Python, like how for prediction, you can do that for Streamlit as well. Basically, Streamlit is just a framework, nothing else. You just type in everything that's related to your Python and then it will work similarly how it works with Python.
Yeah, now I'm clear. Like one question is just small question, like this thing, this is a slider which takes in float values, right?
Okay.
Yeah, we need to take in discrete values or categorical values.
Okay. For categorical values, I'd suggest don't take. I'd suggest not, because you can't basically do a slider for categorical values.
Not a slider, like a drop-down list.
Exactly. You can do a drop-down list that we have shown over here. X-axis CRIM. Basically, you can do this.
So what is like st dot option?
You have to st. Yeah, like I showed you the code. Wait. If you want to push it to the like sidebar, you can do that st.sidebar thing. But if you don't want to push it to the sidebar and put it on your like main part, like you can do st.sidebar.selectbox. But if you want to push it to sidebar, st.sidebar, or if you don't want to, just remove this sidebar thing and stick with st.sidebar. It'll show it to you on the main page of the web app. And then you can pass in your options, like whatever values that you have in your, let's say you have options as A, B, C, D. You can pass on A, B, C, and stuff like that. So that will work just as fine.
Yeah. This, and now I'm asking for this code.
Okay.
But thank you.
Sure. Bye. Thank you.
Nishit, can we have an official tutorial for this particular framework?
Yeah, I guess we can have.
No? So what we can do is that we can share that link so that one who want to start coding from scratch, they can take a reference, right?
Yeah, sure. Could you please share that? I guess the recording will be saved.
Yes, recordings will be shared.
Yes.
Will this be available in our LMS?
Yes, Jatin, this will be available in your LMS.
Yeah. Do you have any more questions regarding the code and the hosting or anything? Please, now's the time you can ask.
Okay, one thing I want to update, the recording will be on LMS, but it will come on request. It will not be given to, it will be given on request. So if you need the recording, we can get it uploaded this by mid of next week. And if you want the recording to be shared, you need to send a mail to care at DataMites and they will give you the access. So please note that. So if you are going to your individual batches and checking for this recording, it will not be available. So yeah, just want to keep you guys posted on that.
I think we have answered all the questions, but still guys, if you have any question, you can ask. We can keep this session active for 2 more minutes. So if you have any question, just put it in QA section.
Oh yeah, by the way, there's another thing, like if you want to like bring changes into the code, like you realize you've done a blunder or something and you want to change it, you no need to upload your files again and again. You can just simply edit your file on your main branch, whatever over here, and it will like save it, commit to your like commit the changes to your like main branch, and then it'll get like automatically updated over here. So you need not again and again upload your files from your local host or your local system. So you can update it directly from your GitHub repository.
Okay, so it seems no more question. Fine, guys. Thank you so much for joining the session. Okay, and yeah, Nishit's last word. Anything you want to?
Yeah, thank you everyone for joining. I mean, it's a Saturday, it's a weekend. Yeah, and basically morning 11. So I know it's tough. I mean, it's tough for me to wake up, to be honest. But I can assume it's winter mornings. It must be tough for you as well. Thank you for taking time out. You've been a great audience. Love the interaction. Yeah, thank you for joining.
Thank you, everyone.